Hey guys, it's Blake back in the garage again, and today we're going to go through some of the setup of the fuel system on my Mustang project. So if anybody hasn't been following along, this is a 1965 Ford Mustang, or at least parts of it are. It's pretty heavily modified, and right now we're going to look through the fuel system that's in it. So people are familiar with the Ford Pinto and its tendency to go all splody because the fuel tank is basically the furthest thing back in the vehicle. And the early Mustangs, really a lot of Ford cars from that era, really aren't all that much better. So this one had the same thing. So I mean, if you look at where the wheel tubs are, and these are mini tubs that I built here. But if you look at where those are, the fuel tank is way behind the axle. And if you look at, where the bumper mounts are these right here. This is a bumper mount, or at least this is the back bracing for the bumper mount. So there's not a lot of distance between it. And this is actually moved back slightly from some of where the original tank sat. So to, minimize the odds of dying in a fire, I have a fuel safe cell in here. And so this has, we'll get under the car and show it a little bit more. You can see the bottom of the bracing, but there is a frame that's welded into the chassis. And then there is a steel box, and then there is a fuel safe fuel cell that sits inside of that steel box. And then there's a lid here that's obviously connected with a whole bunch of bolts. And then we have this little part right here. So this is a Nuke Performance CFC. This is a really cool thing. Essentially what we have here is this is a surge tank that fits inside of the fuel cell. So now, if you're not familiar with what a surge tank or a swirl pod is, essentially it is a small fuel tank. I think this one's like a liter and a half. And there's a fuel tank or fuel pump in the tank, which is powered by these two right here. So that's these two leads. And this is the fuel level center, by the way. But those two leads power fuel pump. In this case, it's a Walbro 190 liter per hour. And that pumps to another reservoir inside of the fuel tank, which is on this side of the lid up underneath. And what's in there is a larger fuel pump. So the purpose of this is that swirl pot surge tank is essentially able to stay full of fuel all the time. And if you take strong corners, accelerate hard, brake hard, whatever, there's such a large amount of fuel in it. It's a small chamber. The fuel is well up above the pickup of the pump, and it doesn't starve the pump. So otherwise, if you consider the whole tank, this is a 22-gallon tank, by the way. If you consider the whole depth of that tank, or the whole width of that tank, if you're down around an eighth of a tank or even a quarter tank and you really take like a long sweeping curve, you can starve the fuel pump. You can also have that same issue under hard acceleration or hard braking. Hard acceleration is normally more of an issue. If you're on the throttle hard and hard braking, probably something's gone wrong. But in the swirl pot on this, because I don't leave anything alone, you'll see this yellow plug right in the center of your screen right there. That is a power feed for a DeechWorks 440 liter per hour brushless, which is pulse width modified or pulse width modulated for control. Essentially what that does is allow me to have a fuel pump that's capable of moving a whole lot of fuel when I ask it to, but I can scale it way, way, way down when I'm just cruising around so that it doesn't heat my fuel up a ton and cause all kinds of problems. So unfortunately though, that is a 4-wire connector. So this Nuke tank, or Nuke lid, has a really nice 3-position here. It's made to handle dual fuel pumps and all kinds of things. With this large fuel pump in my system, I don't need dual, but I do need this 4-wire. So this is actually put in here with a black fuel-safe potting epoxy. It's RT125 from Raycom. So pretty good stuff. It's not going anywhere, and it seals it and keeps fuel from leaking back out. And then I also have, this is supposed to have a fill point where you would have to open the trunk to fill it. That's annoying. So I modified the factory fuel pickup or fuel filler neck to fit this. So this is just aluminum tube right here. This is all aluminum and it bolts in from the top. And then there's a quick Le Mans style cap on the back. So you just pop that open. There it is. Seals like this. Simple. I machined some adapters to make that fit. So outside of that, we have a relay set up here. So this relay basically powers on everything, and we have a fuse set up here. So without going too far into the weeds here, what happens is the ECU turns on this relay. This relay turns on the 190 liter per hour lift pump that fills the surge tank. It also triggers this to turn on, which is a voltage booster. This is what a lot of people generically call a booster pump. This is the MSD equivalent. It works really nice. It's fully programmable. I'm just running it at a flat 18 volts, but essentially this amps the voltage to the DeechWorks up to 18 volts. Since I'm pulse width modulating the DeechWorks from my Haltech for control, the pump is running at more voltage, but it runs a very low load most of the time. So running it at 18 volts, really not a big deal. Having talked to the guys at DeechWorks a few times, they've told me that in the way that I'm running this, I could probably get by with 20. I might even be able to get by with 22 volts, which this is possible to output, but I just don't need it. 18 volts is gonna flow more than enough fuel for me. And then I have the great big honking DeechWorks post pump filter. This is an ethanol compatible, rebuildable. It's got like neodymium magnets in it to pull any crap, at least ferrous crap out of the fuel lines as they move. And then these are all PTFE fuel lines. This is a vent. The vent's down under the car. There's a little filter underneath it just to stop from sucking any schmoo in. And that is important to let the tank breathe. And then we have obviously the output line that runs to that filter. And then we have the return line over here. These come up through bulkheads underneath the car. And I broke my handy little bracket here. I 3D printed a bracket and I was doing something dumb and broke it. I'm probably gonna machine a new bracket out of aluminum. But this is, if you're not familiar, this is a flex fuel sender. And that is essentially the entire setup here in the trunk from a fueling system perspective. And we'll go up to the front of the car and I'll show you what everything looks like there. Okay, so we're on the business end of the fuel system, or I guess the at least the end that uses up all the fuel. And what we've got up here are some fuel rails from Radium Engineering. These are really, really nice pieces. I like that you can't really necessarily see it great from up top here. That might be a little bit better angle, but the brackets are actually machined into it, which is fantastic from my perspective. I've had fuel rails before where the brackets bolt onto the sides and they came loose and it tried to eject the fuel rail from the top of the injectors and made a great big mess. And luckily I didn't have a big fire, but I certainly could have. What we've got here are fuel pulsation dampers. These are, I believe, the XR model. And essentially these do the same thing that a pulsation damper does on a factory car. So as your injectors pulse, it can cause minor fluctuations in your fueling system. And essentially there's scenarios where you can get harmonics and cause problems with your fueling. So I have two of them, mostly because I feed the way that this fuel system's set up. And if you're doing any kind of V engine with a large fuel supply, or even on an inline, you can do it similarly by going into the center here. But essentially, my fuel system feeds up right here with this dash 10. And then you can't necessarily, yeah, you can see it a little bit. So there's a Y fitting right there. And we feed into the front through these 180s on each side. So that Y is from that dash 10 and feeds into both rails. And then out the back, they come back out, they Y together here, and they go to my fuel pressure regulator, which we'll get back to in a second. But the benefit of that design is that you're feeding both rails at the same time. You can run into issues, and we actually have run into issues on some like 1200 wheel horsepower cars where when you feed into one rail and then feed out of that rail and into the other one, so a lot of times people will feed into like the back of the rail, then they'll come to the front, they'll cross over, go through the other rail, and then go out to the regulator. That's a lot less money in fittings. It's a lot less line. It's a little bit lighter, but it has the problem of you can start to starve. By the time you get to these back couple injectors here, you can get to the point where even your dash 10 can start to starve the fuel system. Whereas if you Y it before the rails and you feed into both of them, you've only got to supply enough fuel to feed 4 injectors per side. So it's just a little bit safer. Again, on like something like a 2JZ, sometimes you might feed into the center of the rail and then return for both ends so that your feed only has to feed 3 injectors from either side. But it's just something that makes it a little bit safer. But because of that, I have essentially 2 separate, completely isolated fuel rails. So I have 2 fuel pulsation dampers. So again, it's kind of a case of better safe than sorry. I've also got a mechanical fuel pressure gauge here. I like these because it allows me when I'm tuning the fuel pressure on the fuel pressure regulator under the hood. I have a kind of a sanity checkpoint. So I've got a really nice pressure transducer on it that reports to my ECU. for tracking and safety and all kinds of things. But when you're doing your initial pressure setup, it can be really nice to have a mechanical gauge as you're sitting there adjusting it. And also just to sanity check your transducer sometimes. So right here is our fuel pressure regulator. This is another radium piece. So I made a change to all the radium stuff under the hood recently. I've been pretty pleased with the quality of their hardware. So again, we've got a lot of PTFE lines here, so that we're E85 compatible. And then we have a WHP pressure transducer. I got that from the ECU Master distributor here in the US. Again, really nice part. Been really, really pleased with the quality of it. And for anybody curious, I am running a 43.5 PSI or 3-bar base fuel pressure. So that's what I run. This is a 1-to-1 boost reference setup. So yeah, I've got another set of transducers over here. I've got a cheap eBay one on the ECU for the oil system right now. There's actually, I have another WHP sensor on order here. But yeah, that's essentially the fuel system in the car. Oh yeah, one other pertinent detail. I don't know if you can see it, those little guys buried down in there. Those are ID 1050X injectors. So I'm a big fan. I've run ID injectors on a couple of cars. They're really, really nice quality. They don't get grumpy with E85 as long as you know, keep them running. If you're going to store it in the winter with E85, you need to keep the engine running on a regular basis so they don't get gummed up and stuff, and check them occasionally get this weird black goo from E85. So just, you know, be smart. But if any injector is going to tolerate it, the ID stuff is really, really nice. So, but yeah, so that's the fuel system in the car. And we'll go through in another video here and kind of go through what I've got under the hood for electrical system, and kind of how I'm doing some of that stuff with the Haltech and things. And then we'll also go through the suspension work that's done on the car.